Hi, it's Richard again from Mobineko, back with the second part in a series that dives into the science of vinyl from cutting to pressing. In my first video, I showed you the basic parts of a lathe and we saw a lacquer being cut. It's probably a good idea to watch that first, so if you haven't seen it yet, I'll leave a link down below. Whenever someone comes to a cutting studio for the first time, the part that everyone loves is zooming into the lacquer with a microscope and seeing that groove close up. So let's do that now and start off with the building blocks of a cut. Here you can see what horizontal modulation looks like. This is the easiest way to get a mono signal on disc. The stylus moves left and right to cut music into the lacquer with a fixed depth. Some early disc cutting systems work just like this, with a single coil, and there are actually people still cutting with those systems today. Vertical modulation is another way to get a mono signal onto disc. Again, some early systems use this technique. Mechanically, it's slightly easier to build a head like this, but there are quite a few downsides. Vertical modulation needs precise depth calibration. You have to be very careful with levels, and there's a risk that the stylus will jump right out of the groove. You might be wondering how we get stereo out of a single groove, and this is where things get tricky and very clever. Two separate coils laid out at a 90-degree angle can modulate one channel vertically, up and down, while the second channel modulates horizontally, left and right. Now, we just talked about how cutting vertically at 90 degrees to the disc is not good, but there is a solution to this. If we just rotate the two coils by 45 degrees, you now have a modern cutter head. Looking at the side of the head, you can see how the coils are laid out in a V shape, and when we inspect the groove under a microscope, you can see how modulating the left and right channels separately affect the groove. Those three lines you can see come from the edges and tip of the cutting stylus. These two stronger in-focus lines are the groove walls, and the center line is the bottom of the groove. So when we just feed a signal into the left channel only, one of the coils is moving, and you can see how one side of the groove is now just a static line. Here's what it looks like when we feed a signal into the right channel. We can still cut a mono signal with a stereo head, and it looks like this. You'll notice that both coils are now locked at the same depth, so with a mono signal, we're only using the horizontal plane. With a stereo signal, the groove geometry now gets a lot more complicated, so you have everything moving up and down and left and right, with all kinds of frequencies laid on top of each other. That's all the basics down. The next part is where modern technology gets involved. Music is a complicated mix of different frequencies, and we need a way to adjust the pitch between each revolution so the groove can just about fit without taking up too much space or crashing into itself. If one groove collides into the next, that's called an overcut, and you end up with a skip or a loop. On the other hand, if the grooves aren't packed tightly, then you're losing out on potential level or bass that you could fit on that side. Almost every professional studio today is using some kind of pitch computer. The pitch computer's job is to listen to the audio signal coming in and predict how much space is needed to fit each revolution around the disc. To do this, we actually need two pairs of stereo signals from the audio workstation. The first stereo pair comes directly from the real-time audio and feeds into the pitch computer. The second stereo pair is delayed, usually by half a revolution, and fed into the cutting amps. So the pitch computer is always half a revolution ahead of the cut and constantly adjusts the speed of the pitch motor to keep the grooves tightly packed without any overcuts. The easiest way to understand how this works is to feed some different signals into the lathe. Here's a 1 kHz mono signal. You'll see that it's not taking up much more space than a silent groove. Now if I change this to a 50 Hz bass tone, you'll see there's a massive difference in the amount of space that takes up. If I bring down the level of this same tone, that makes the waveform physically smaller and the pitch computer starts to adjust the pitch back down. Now, a modern pitch computer is a really useful piece of kit, but it's not magic. If you try to cut audio that's too hot or has too much bass, then the computer is going to hit the limit of the pitch motor and you end up with overcuts. The human operator also has a lot of decisions to make about the overall cutting level and what kind of hardware or software processing would make the record sound good. One very special feature our computer has here at Mobineko is a timing calculator. We can feed it some music and it will tell us roughly how much of that music would fit. This really helps get things dialed in perfectly. If there's not enough space, we can start reducing the level or bass or if we see there's room to spare, we might want to bring up the levels for a hotter cut. This is going to come in handy when I show you some examples in a minute. Now you have this foundation of knowledge, I want to give you my 3 do's and 3 don'ts for vinyl mastering. I'm going to start with the don'ts because this first one will make the biggest difference to how your records sound, in my opinion. First off, don't overcompress or limit your final master. This can be very non-intuitive even for experienced mastering engineers, but a hot brick-walled master has to be cut quieter on lacquer than a dynamic master. Even if it sounds great on Spotify, it will probably not sound great on vinyl. I know this might be hard to understand, so let's look at the microscope while we cut a nice dynamic pre-master of an acid house track. By the way, big thanks to our UK support guy Josh for letting me use this audio. There's a link down below to his label Balkan Vinyl, so go check him out. The pitch computer's working hard with this master. It's constantly adjusting the pitch motor and fitting each revolution in like a jigsaw. Now I've done something quite naughty and I've really overcompressed that same pre-master. If I left this cut at the same level, the pitch computer needs to use a lot more space, and if this was a full side, it just wouldn't fit. So I'm now going to adjust the level where it would use just about the same kind of space as the pre-master. You should be able to see that the pitch computer is almost working with a kind of fixed pitch now. There are no dynamics left, so it just has this wall of sound to deal with. Those clip peaks are also going to cause havoc with a playback stylus. Analog turntables are really not happy when confronted with that. Let's play back those 2 cuts directly off the lathe and have a listen. So yeah, if you want a hot cut that's not distorted, then leave some dynamics in your master. Don't cram too much material on one side. I know it's difficult to cut something down that you might have spent months or years working on, but this is very much a case of quality over quantity. For best results, we're aiming to get the audio into the first 2/3 of a side and avoid the last third in the middle. I'll show you why in a moment. One way to do this is to cut quieter, but that's not always possible, and most people want their record cut loud. The other way is to cut shorter sides, and this is absolutely the easiest and safest way to get better sound out of a record. If you have a master that's 23 minutes long, if you cut that exact same master down to 18 minutes, it will always sound better than the longer version. You'll have to trust me on this. It doesn't matter how good the engineer is, a shorter cut will always sound better. I've got a track here that's quite busy with hi-hats and other high-frequency components. Let's cut a short clip at the very outside edge of a disc. On the outside edge, the stylus is moving at a pretty quick pace. The circumference is about 37 inches, so at 33 RPM, that's around 20 inches per second. Now we'll cut the same clip at the inside. Here the circumference is maybe 12 inches, so that's only around 6 inches per second. Visually, you'll see that the inner diameter cut is a lot more cramped, and there's not really enough room to track those fast-moving, high-frequency waves. In the vinyl world, we call this diameter loss or inner groove distortion, and it's one of the most common complaints I see from customers. Let's take a listen to those clips back to back so you can hear the difference. I said that we're aiming to keep any music away from the center of a disc, and hopefully you can understand why that's so important now. I've had some difficult conversations with artists where they felt they've been shortchanged because a cut isn't absolutely crammed to the brim, but that doesn't mean you're losing out on anything, and it doesn't make the cut sound any louder or clearer. So how long is too long? Well, that would be a whole other video in itself, but if you head to mobineko.com, you can check out our vinyl time per side wizard. It's not perfect, but if you plug in some info like the musical style and format, it will give you a very rough idea of what to expect for a certain number of minutes on a side. If you insist on a number, then I'd personally keep rock or pop LPs to 19 or 20 minutes maximum. About 15 minutes for a hip hop or dance EP, and somewhere around 6 to 8 minutes for a loud club single. If you have an hour or more of material to get on vinyl and you want to keep it to a single 12-inch, my practical advice is to keep the record under 20 minutes aside and offer your buyers a download card or maybe even a CD. You can host your album somewhere like Bandcamp and include a unique access code inside the sleeve. That's great for everyone because the artists get to release their full vision to the world, the vinyl still sounds great, and the end buyer gets their vinyl and a bonus digital version. Finally, don't over-process audio based on what you've read online. Look, the internet can be a great resource and there's some good information in general about mastering, but there's also a lot of absolute nonsense and bad advice. Someone hears something that someone once mentioned about making records, it gets twisted over the years and then gets passed along as if it's solid advice. A good example of this is controlling stereo bass on a vinyl master. Even I've been guilty of this. I used to suggest applying an elliptic EQ on everything, so any bass under a certain frequency like 200 or 300 Hz gets monoed. But then I thought, hang on, it's the cutting engineer who should be doing that stuff. Every piece of music is different. Nothing says that you have to mono stereo bass on every track. A lot of music just doesn't need it, and some tracks might have really bad phase issues that need quite an aggressive treatment. You should still listen to your audio in mono though before sending it out. Another thing that I've seen clients get very confused about is headroom, and a lot of this comes from forum chatter. You don't have to send a really quiet finished master for cutting. It's fine if your peaks hit 0 dB as long as they're not clipped. The point here is mix your music so it sounds good. EQ it how you like it. As long as you've not wired half your mics backwards and you've not overcompressed your master, just get your master sounding how you like it. Let the cutting engineer deal with the physical mechanics of getting the music onto disc. Those are my 3 big don'ts for vinyl. How about what you should do? First off, do ask your cutting studio for advice. You're paying money to someone to cut and press records for you. It's perfectly acceptable to ask questions and get help. Any decent cutting engineer would absolutely prefer that you ask for advice before a project is started. It makes our life easier, it stops the client getting stressed. There's really no downside to having this communication line open. Talk to the professional you've hired. Even better, send them some audio clips and most studios will be quite happy to give you feedback. Do lay out your tracks carefully. If at all possible, put your tracks with a lot of mid to high frequencies at the start of a side. You might have heard people say that loud tracks should go at the start and quiet tracks at the end. It's not wrong, but it's also a bit more nuanced than that. We just went over the perils of long sides, but it's so important, I'm going to put this graphic up again. The same physics that make long sides a bad idea also dictate how you should best lay out your track list on vinyl. The longer your sides are, the more important this is. Once you start getting to 21, 22 minutes or more, that inner third of the disc can get really crunchy on high frequencies. If you have a vocal with lots of sounds or piano or just a really loud busy track with hi-hats, try and figure out a way to keep that towards the outside. Finally, do DS your vocals and hi-hats. Cutting heads really hate bursts of high frequency sounds. They need a lot of power to cut, and turntables don't like playing them back either. The worst culprit for this is vocals with what we call plosives like pff and s sounds. If you don't tame these at the mixing stage, they can get very crunchy and unpleasant on disc, and this is another common source of complaints that I hear. There's not much the cutting engineer can do about these plosives from a finished master. Running DS's on a final mix is a bad idea that's going to make the mix sound dull and muddy. I would recommend running a fairly aggressive de-esser plugin on any vocal or hi-hat stems at the mixing stage. It will make your record sound so much better in the end. We've now covered the basics of cutting, but before we move on to the next steps of plating and pressing, I wanted to wrap things up with a couple of questions that I get asked a lot. First off is how to physically prep audio files for a cut. You should ask the studio you're planning to use first, but personally, I prefer when clients send a single file for each side. I will play that back directly off the workstation so everybody knows exactly what you're going to get with regards to layout and track breaks and so on. If you want to send separate tracks, I'm fine with that, and most studios are too. But if your studio or plant doesn't ask for this when ordering, make sure you provide a detailed track list that confirms the sequencing, including the sides and any silence you want between the tracks. Be organized when you're prepping tracks for a cut. It absolutely amazes me when someone is spending thousands of dollars pressing their records and the audio files are thrown into a folder like they're garbage. Name your files properly: A01, A02, B01, B02, and so on. Put them in a folder named after the catalog number or order ID and zip that folder to send to the studio. The reason why you should do this is there is no error control built into WAV files and the internet isn't perfect. When you zip a folder, it adds something called a checksum to the archive. And if something got corrupted on its way across the internet, zip will stop you from opening the files. I just said that I prefer a single audio file per side, and lots of people ask if that means they can still get markers between the tracks. That segues into the next question, which is how those markers, sometimes called spirals or track breaks, actually get onto the disc. These are actually done manually, or in our case automatically, by the cutting computer applying a quick burst of speed to the pitch motor. This doesn't affect the sound at all, so you can actually do this in the middle of a track if you really wanted. The important thing is to give your studio or plant a proper track list that shows where you want each marker to be inserted. The last question I'll cover here is how a locked groove works. Almost every record has a locked groove at the end of each side to stop the stylus flying into the label, but it's usually silent. And I'm talking about a locked groove with sound that repeats every revolution. It's actually very simple. The lathe's constantly pushing the carriage forward very slowly, so all the grooves get laid out in a spiral from the outside in. At the end of a disc, well, actually it could be anywhere on the disc, if you keep cutting without the pitch motor spinning, you end up with a perfect concentric circle. If you play that back, the stylus will just keep going round and round inside the circle, and if you time it just right, you can put some kind of fun sound or infinite track ending in there. Thanks for watching so far, and I hope you learned something. I love talking about vinyl and sharing knowledge, so if you have any questions that I've not covered, please leave a comment and I'll try to respond. This is my first time making a long format video, and it's taking a lot longer than I expected to get everything together. So I'm not quite sure how long it would take to get the next part ready. It might be worth subscribing if you want to get notified when we get around to part 3.